less than or equal to based off the symbol. You should be able to solve an inequality, and you should also be able to graph the solution set of an inequality on a number line. So let's get to our notes. When we're solving inequalities, they work the exact same way that an equation works, in that you are going to use your inverse operations to isolate a variable. Okay, so you're going to get the variable alone on one side of the inequality, and it works exactly the same as if it was an equal sign. The one thing you have to be very, very careful of with inequalities different from an equation is we need to flip or turn around our inequality sign whenever we multiply or divide by a negative number. It's going to change the direction of your inequality. All right, so let's try this so you kind of get an idea of what I'm talking about. So we want to solve for x. We're going to use the same rules. If that was an equal sign, it wouldn't make any difference. So you always add or subtract first. So I'm going to subtract 2 from both sides, and I end up with 3x is greater than -6. Now to get the x alone, you're going to divide both sides by 3. 3 is a positive number, so we don't have to worry about flipping our inequality here. That cancels, and I have x is greater than -2. Sorry about that. -2. Alright, well let's try another one. See how we're doing. So I have 2 terms on this side. I'm trying to get into that x. We cannot reach that until the fraction is the only term on that side. So that means we need to get rid of the 2 first. So we're going to subtract 2 from both sides. And I'm left with x over 6 is greater than -3. Now to get the x alone, we need to get rid of the denominator. So we're going to multiply both sides by 6. And I have x is greater than -3 times 6 is -18. And one last solving before we move on to about solutions. I'm trying to get the x, so I need to get it down to one term to be able to do that. So I'm going to subtract 8 from both sides. I'm with -7x. This symbol is less than or equal to 1 minus 8 is -7. Now to divide this off, I'm going to divide both sides by -7. So remember when I said if you divide by a negative number, you have to flip your sign around. So I'm dividing by a negative number. So instead of pointing to the left, it's going to change directions. And now I have x, and -7 divided by -7 is a +1. And that will be our answer. Alright, so whenever we solve an inequality, we come up with solutions. Okay, so we have a solution to an inequality is a number that produces a true statement when it is substituted in for the variable in the inequality. So here I'm asking you decide whether or not 4 is a solution to the inequality. So instead of x, we're going to substitute in 4. Okay, so I have 2 times 4, which is 8, minus 1 is less than 8. 8 minus 1 is 7. Is 7 less than 8? Is that a true statement? It is a true statement, so 4 is a solution. Alright, let's try it again for B. So we have our x, and remember we said we wanted the x to be 4, so we're going to say 4 plus 4 is greater than 9. 4 plus 4 is 8. Is 8 greater than 9? It is not. So 4 is not a solution. A solution makes the inequality true. Okay? One last one. Substitute in 4 for the x. 4 minus 3 greater than or equal to 1. 4 minus 3 is 1. Greater than or equal is 1. Greater than or equal to 1. Well, 1 is equal to 1. So 4 is a solution. All right. So we'll do a quick review here before we move on to our next set of the symbols. So we have less than symbols, and that's a less than, because you always read the statement left to right, so the small side of the symbol is pointing to the smaller number. That means the first number is smaller than the second number, so the first number is less than the second. Or when you add a bar in under it, it's less than or equal to. Okay? Then we have greater than. Greater thans go the other way. So when you're reading left to right, the left-hand number has the bigger side of the symbol next to it because the left-hand number is bigger than the right-hand number. The left is greater than the right. Okay? And then you could have it with a line under it, which means or greater than or equal to. Okay, so you're going to want to be sure that you learn these because it'll make this process a whole lot easier. All right, so now we've solved, we've talked about solutions, and now we're going to graph these also as part of this. So the graph of a linear inequality in one variable is the set of points on the number line that represent all solutions of an inequality. So we solve an equation, there's only one number that makes the equation true. But in an inequality, there can be a bunch of numbers that makes the inequality true, okay? And so they're all solutions. So when we go to graph these, there's two symbols I want you to remember. You have an open circle and you have a closed circle. An open circle means your graph does not include a number. So it's not part of the solution. And you're going to use an open circle if you have a less than or a greater than. A closed circle means your solution does include a number. And you will use it when you have equal to signs underneath your inequality. Okay? So I'm pretty sure you guys have done these before, so we're going to do a review of what these look like. So we have a verbal phrase here. All real numbers less than. So less than is this symbol. And when we translate that, we have all the numbers that are less than 2. So when we go to graph this, there's not an equal sign, which means an open circle. So above 2, we're going to put an open circle, and then we're going to shade everything that goes to the left, because that's less than 2. All those numbers are less than 2, and it goes forever and ever and ever to the left. -3, -1,000,000, -2 gajillion. All of those numbers, when you substitute them in, will make the statement true, the inequality true. However, 2 substituted in does not make it true, because if I write 2 less than 2, that is not a true statement because it doesn't include equal to. So 2 is not included in the solution, but all these other numbers forever to the left are. Let's try the second one. So we have all real numbers greater than 2. So all numbers greater than -2. So it's not an equal to symbol, so you're putting an open circle over the -2. And it says all numbers greater than -2, all those are to the right. So you would be shading all to the right, and it goes forever and ever and ever to the right. It never stops. So If you substituted in -1 is greater than -2 because it's less negative. 1,000,000 is greater than -2. 2 googolplex is greater than -2. You can keep going to the right forever and ever and ever, and this statement will always be true. But if you substituted in -2 here, -2 is not greater than -2. So that's why it's an open circle. It's not included in your solution set. It's just giving you kind of a starting point. Our third example, all real numbers less than or equal to 1. So less than or equal to. So all numbers less than or equal to 1. So to the 1, you've got an equal to sign. So you're going to go to where 1 is and put a closed circle. And all numbers that are less than that are all the numbers to the left forever and ever and ever, including the number 1. If you substitute the 1 in there, 1 is less than or equal to 1. That's a true statement, so that's why this is a closed circle, because it includes that answer. And our last one, all real numbers greater than or equal to 0. So 0 is where we want to start. It has an equal to symbol, so we closed it in, and numbers greater than 0 are numbers to the right, so you're shading to the right forever and ever and ever to the right. So if you check, like if you check these numbers you didn't shade, -1. If you substitute -1, is -1 greater than or equal to 0? It is not, because it's not in the shaded area. Anything in the shaded area is a solution. If it's not in the shaded area, it is not a solution. So let's try some examples here and see how we do. So we got some solving and some graphing. So I want to start to solve. I've got 2 terms, one of which is this fraction with the variable in it. So we can't deal with that fraction until it's the only term on that side. So we're going to add 5 to both sides. And I have x over -8 is less than 2 plus 5 is 7. Okay? So now my fraction is the only term on the left-hand side. So I want to get the x alone, so I got to get rid of the denominator. So I'm going to multiply by -8 to both sides of the inequality. Now, remember the rule. If you multiply or divide by a negative number, what's going to happen right here is this is going to change directions. Okay? And so that cancels out x. 7 times -8 is -56. So when you were in middle school doing this, you were probably required to label all of these points. I really only care about this number. So I usually put it in the middle, -56. There's no equals to sign, so I'm going to use an open circle. And I want the numbers that are greater than or bigger than -56. The numbers become bigger when you go to the right, so I'm going to shade to the right, and I'm going to stick an arrow on it that it's going forever and ever that way. So if I asked you, is 0 a solution? Well, 0 is over to the right somewhere, so 0 would be a solution. Would -57 be a solution? Right here. No, because it's not in the shaded area. It has to be in the shaded area to be a solution. Is -56 a solution? Well, it's not actually in the shaded area. It has an open circle, so -56 would not be a solution. Let's try number 2. Okay, so we're trying to isolate this -2x so we can get x alone. So we're going to add 5 to both sides of the inequality. These guys cancel, and I'm left with -2x is less than or equal to 19 plus 5 is 24. To get x alone, I've got to divide by a negative. So I'm dividing by a negative. What happens is my sign is going to change directions. And I'm left with x is greater than or equal to -12. So I'm going to just stick -12 in the middle. There's an equal to sign, so I'm going to have a closed circle. Where are numbers greater than -12? Greater than shades to the right. So I could ask you a bunch of questions about numbers that if they're solutions. Is -13 a solution? -13 would be right here. Is it in the shaded area? It isn't, so it's not a solution. Would -12 be a solution? Yes, because the circle is closed in, so negative 12 would be a solution. Would 1,000 be a solution? Yes, because it's way far to the right over here somewhere, but it would be in the shaded region because our line keeps going. All right, let's try number 3. We're trying to get the x alone, so we're going to subtract 3 from both sides. We get negative 4x is less than 28. To get x alone, we got to divide by negative. So instead of less than, we got to have a greater than. These guys cancel, and we have x is greater than 28 divided by negative 4 is negative 7. There's no equal to, so you have an open circle. And then greater than a number is to the right. Okay. So would 0 be a solution? Well, where is 0 in comparison to negative 7? 0 is over here, so yes. 0 would be a solution. Would negative 7 be a solution? No, because we have an open circle, not a solution. Would negative 10 be a solution? No, it's not in the shaded area. Okay. All right, let's try number 4. Let's isolate the x. So we're going to subtract 5 to get us started. And we have 3 over 4x is greater than 11 minus 5 is 6. So there's a couple ways to get rid of this fraction right in front. Because we want the entire fraction to go away, I'm going to say multiply by the reciprocal. 4 divided by 3. 4 divided by 3. Remember that 6 is over a 1. We did that because this cancels this whole fraction to a 1, leaving just your x. We did not multiply by a negative number, so our sign stays in the same direction. And we have 6 times 4, which is 24, over 1 times 3, which is 3, and that's going to reduce to x is greater than 8. There's no equal symbol, so that's a open circle. Greater than a number, it's going to be shading over to the right. All right. Pause the video. Try the next 2 all on your own, and let's see how you did. Alright, so when we look at number 5, added the 1, but then here when I was trying to isolate the x, I had to divide by a negative, which changed the direction of my inequality. Okay, so that one. Right, so it changes the direction of my inequality. And 15 divided by negative 5 is negative 3. So my important number was negative 3. It had an equal to, so closed circle, less than is everything to the left. Right? And then number 6. Add 2 to both sides to get it started. 5x is less than negative 5. You're dividing by positive 5. So your inequality stays in the same direction. X is less than or equal to negative 1. So negative 1 is my important number. Closed circle, and less than is to the left. All right, I hope that was helpful. If you have any questions, let me know. I'll see you in class.